Everybody. Welcome to another episode of the Student Spotlight series, where we showcase some of the work our past students have done. Today, it is our pleasure to have with us Manraj Miglani. So, Manraj, tell us a little bit about yourself, where you're from, what year of school you're in, and a little bit about the course you've taken with CCIR.
I'm Manraj Miglani. I'm a junior at Northwood High School, which is in Southern California. So I took an online course at CCIR, and the course was Neuroscience and Neurotechnology, Understanding and Enhancing the Human Mind, which was led by Dr. Amparo Gomez Gonzalez.
So, how did you become interested in the program?
Um, so I think I was really interested in the idea of research. So before taking this course, I was thinking about going into the field of biotechnology, which is a very massive field, lots of aspects to it regarding both medicine and technology. Um, but with research, I wanted to figure out what I like and dislike about biotech. And then also I wanted to get good exposure with research beyond high school, because I know that in college, that's a big part of what you do. So overall, that was why I wanted to do research, but CCIR specifically, I think I was really attracted to the opportunity that you're given with such high prestigious colleges, universities, and that name factor, and then also how the staff actually I feel like with being such prestigious universities, the staff really know what they're teaching you, and you get a good experience out of it.
Mm-hmm. So, how is the course structured? I guess what was the sort of kind of knowledge aspect of it, and what was the sort of research aspect of it, I guess maybe would be the question.
Yeah. So the course was split up into two sections. There was a lecture session and a TA. So there were two classes per week for 13 weeks. So the first part, the lecture, was led by Dr. Amparo. She would teach us about some of the basics of neuroscience and the topics that we need to know for doing our research, like what is a neuron, how do signals send, and how do our sensory systems work, stuff like that.
Mm-hmm.
It really created a good basic understanding, because a lot of these topics were really new to me, because I had no knowledge of neuroscience. So that was the lecture part, and then the TA part was led by Miss Bella Hyder, and she was really helping us with guiding through our research, telling us what research was, different kinds of research, how to do it, how to read, how to organize, stuff like that.
Mm-hmm.
And it was really beneficial for, learning how to write a research paper for the first time. So,
Mm-hmm. Can you say a little bit about what your research project was?
yeah, I did, my project was about optogenetics. So specifically, how can we use optogenetic manipulation of pain-related circuits to alleviate pain from trigeminal neuralgia? So it's a mouthful, but
Yeah.
yeah. So it's a review of how different regions of the brain that are intertwined with pain management can be switched off in a way so that we can alleviate pain from trigeminal neuralgia. So optogenetics is it's a technique in where you genetically engineer specific cells. So in our case, it's neurons. And you introduce light sensitive proteins called opsins.
Mm-hmm.
And these neurons can respond to light. So a specific wavelength would be delivered to the tissue, and then it would respond to light, and then it could either activate or inhibit the neurons, their activity. So that would be optogenetics. And then trigeminal neuralgia was it's a neuropathic chronic pain disorder. So what happens is your trigeminal nerve, it's you receive sensory information from your face and it sends to your brain. That's what your trigeminal nerve does. And
Mm-hmm.
what happens is that nerve gets either constricted or demyelinated, so it gets damaged, and then that causes really excruciating, sharp, sudden, quick episodes of pain. So like when you're eating or brushing, or simple things like that, it causes really bad, really harmful pain that like ruins our quality of life.
So how did you choose that topic, and what kind of support, if any, did you get from your instructor and your TA in picking a topic?
Um, so I think coming into the course, again, I had like very little knowledge with neuroscience, because I was originally like thinking about biotechnology. But um, I think for that topic specifically, what happened was I was just trying to research like what are some big problems in society that I could really do research about that's within the scope of neuroscience and neurotechnology. And I realized like chronic pain is such a big problem in society. Like it's very hard to cure, hard to treat. The treatments that do exist have like lots of side effects, like being like too drowsy to drive or do outdoor activities, and then like addiction. Like, that's those are some really big problems. I was like, I really want to look into that. And then also, um, so optogenetics, I was researching what are the modern ways to solve chronic pain, and I came across optogenetics when doing my research. And then I wanted to be a little bit more specific, so I was like, trigeminal neuralgia is such a like it really hurts to think about that people have to go through that. So I was like, I really want to look into that because it's important.
Yeah, definitely. So then, what was the research process like, and what kind of methodology did you end up using for your paper?
So I did a literature review. So a lot of the time I was doing researching was reading papers and really understanding what I was reading about. Um, like I haven't had much prior information or exposure to research. So like the fact that there are so many big words always put in like every word next to each other. There's like all these different like things that I would have to look up just to understand what I was reading.
Hmm.
Um, but yeah, it was like a lot of reading, a lot, and then figuring out okay, what does this mean, and how can I apply it to my paper, and then give my own insight about it. That was a lot of what I was doing.
So then, what was the method that you ended up using for the paper itself? I guess what were you, was the paper itself a literature review or
Yeah,
some
it was a literature
meta-analysis?
review.
Okay, gotcha. Um, so I guess what kind of picture did you get of the literature in the end? What was the sort of takeaway?
I guess like the biggest takeaways is that like yeah, there is definitely a correlation, or there's definitely like um what's the word, like there's sorry, the specific regions of the brain that I researched did show signs of pain reduction, or at least like a loss of pain perception. So a lot of these studies are done on rats because optogenetics is such a like new field, right?
Mhm.
So all these studies have to be done on rats or like non-humans because well, one, optogenetics is so new, and two, it's really invasive. So we just don't know yet. So
Mhm.
the pain signals that we would that I would acquire would be like through behavioral changes of the rats. Um, so like they might be more withdrawn, they might guard themselves. That's typically what you'd see in rats that are like under this model of pain, under the model of trigeminal pain.
Mhm.
Um, and then what I gathered was that when optogenetically modified, the pain signals seem to have reduced in the rats. So like an example of this would be one of the regions that I looked at, or it was more of a pain pathway, is called the trigeminal nucleus caudalis, or the TNC. So it's like a pain pathway, and one of the studies that I looked at for the review was how like these fibers called corticotrigeminal fibers, they're like these fibers that carry signals from the cortex to your trigeminal nerve. Um, these fibers create really strong connections with GABAergic neurons, which are like inhibitory neurons. So when you um, are exposed to pain, then these GABAergic neurons are released, which inhibits the pain signals. So when these cortical trigeminal fibers form connections with GABAergic neurons, you see a higher activity of GABAergic neurons, which overall inhibits the pain perception. So that was what I was like, that's what I was looking for. And I was like, and that was seen throughout all of the brain regions that I analyzed. So
Mhm.
I was looking at four main regions. Um, and yeah, they were all similarly like, okay, you optogenetically modify um, like one pathway, and that would lead to inhibition of pain. And however, they all had their like own little twist to it, of course, because not every region of the brain is the same, and they all delve with pain in a different way.
Mhm. So, do you have any thoughts on what the obstacles would be to, I guess, actually developing these as clinical treatments?
There is like in my discussion, I did talk a lot about the future of optogenetics because it is so in such a preclinical like phase. A lot of the research I was doing was within the last 2 3 years. So
Mhm.
um, definitely work. The scientific community should work on like a method of optogenetics that is much less invasive so that it could be viable for human trials to occur rather than um so I came across this thing like it was like an ethicality standpoint of if we were to do human trials, we it's kind of unethical for the control group because they would have to get like all these devices implanted in their head surgically and then delivering the options, which is genetic modification. It's kind of like irreversible. So like
Right.
if you're the control group, like what do you gain out of it?
Mhm.
It's such a big process. So it's like it's it's a very big procedure, but it does have very potentially good rewards.
Mhm. So you would say a lot of the biggest obstacles to developing a clinical treatment based on optogenetics is just ethics issues.
Ethicality, the fact that it's irreversible, affordability and accessibility. Yeah, those are like some of the main problems with it.
Mhm. Do you feel like there's a clear path towards solving any of those problems, or is it just more work needs to be done?
I think definitely working on researching optogenetics as as a whole because it's so new. Um, but yeah, there's definitely like there is a vision for what genetics could be in the future, especially in the realm of pain management. Because right now, optogenetics is more so like on a like in like clinically, it's more focused on right now, like your eyes. There's been like a lot of, or I think recently, someone got. I'm not sure about this, but someone got their vision back or something similar along those lines through optogenetics, and I was like, wow, that's really cool.
Mhm.
But there hasn't been a lot of progress done in like the pain management realm.
Mhm. So maybe I should have asked this question earlier, but as a complete layman, could you help me understand a little bit more clearly, like what an optogenetic treatment looks like? I know you said it was about, applying certain wavelengths of light to certain
Yeah.
neurons.
So what happens is you genetically modify like the your cell, or okay, in our case the neurons. So what you do is you implement a gene. This gene is like a light sensitive protein called an
Mhm.
opsin, and this opsin is like it could react to light. So either depending on what opsin it is, it could either activate the neuron or it would inhibit the neuron.
Mhm.
So if the neuron is like, oh, so the GABAergic neuron, right? I was talking about that before. Um, it is an inhibitory neuron. So if you want to reduce pain, you would want to activate the inhibition of signals. It's kind of confusing, but um, on the other hand, if there are neurons that send more signals to your brain, or sensory signals, you would want to inhibit that. So then you would use the specific option for inhibition.
Okay, so I understand better. It's a way to have sort of a kind of granular ability to activate or deactivate, so to speak, certain parts
Yeah.
of the brain. Okay. Ah, that's really interesting.
Mhm.
So, what do you think the most challenging part of the process was for you when you were writing your paper?
Definitely like understanding what I was reading because
Mhm.
there were a lot of big words and processes that I didn't know. Also, the fact that neuroscience was just such a new concept to me. Um, and then also, um, yeah, putting that information down onto like the way I wanted it to be read through like my research article. I wanted it to say like I wanted it to be perceived one way, and that was very difficult. Also, like there is such little research in this topic, it's really hard to like find good articles that you could cite. So yeah.
Mhm. So, what kind of support did you get from your instructor or TA in, I guess, navigating the literature like that?
Oh yeah, they were really beneficial in this whole process. They like my TA was very like open to helping us. She was very um she basically just like taught us everything we needed to know about research, about like anything you needed to know about the entire process. And then she was open to questions all the time. There were office hours. Um, it was very just like a acceptable. There was an acceptability factor that I really enjoyed with CCIR.
So, do you feel like that whole experience has prepared you well to do research in the future or made you, I guess, more interested in pursuing a career that involves research?
Yeah. Before coming into this course, I think I already knew that research was going to be a big part of like my college life because I just want to pursue research. I just think it's so cool. Um, and this definitely like strengthened that desire to pursue research. So yeah, and this definitely taught me a lot of the skills that are needed to pursue research.
So, are you planning on submitting your paper to any journals or taking it to any conferences?
Yeah, I'm taking it to a conference in April,
Mhm.
and then I am going to potentially apply for a journal very soon.
Very cool. So, is there anything that you wish that you had known earlier, or if you were to encounter someone who had minimal research experience who was going to do a similar program, do you have any sort of advice that you might give them?
Yeah, I think at first when I was coming into this program, I was intimidated by the like top like the very big names, Cambridge is a big name, Oxford, et cetera, et cetera. So I was intimidated by that and I was like scared that all the people around me would just be so much smarter than me and know so much more. But I think in reality, like we're all in the same boat and like we're all trying to learn, we're taking this course to learn how to do research. And there may be someone that already knows how to do research, but it's okay, they're not gonna judge you. And yeah, it was just like a really great and open experience. So don't be intimidated and definitely like explore new things. Like all of this optogenetics and neuroscience was completely new to me, but by the end of it, like I'm really glad that I learned more about it.
Yeah, I think that's really good advice. It reminds me of a Miles Davis quote. I'm paraphrasing, but he said something like, "If you're the best player in your band, you need to find a new band." Like, even if it is the case that like you're, going to be somewhere where maybe you feel like you're not quite on the level of everyone else, which often isn't even the case. But even if that is the case, that's not a bad thing because I think that's a good way to learn. So yeah,
Yeah,
I
for sure.
think it's definitely important not to feel intimidated. Yeah. Do you have any other final thoughts about your experience?
Um, I'm grateful for the experience that I had with CCIR. It was very beneficial, gave me great exposure to the research world, and definitely like amplified whatever feelings of I want to go into biotechnology, or now in this case, like neurotechnology is a subsection of biotech. I was like this is really cool. It might be something that I want to pursue in the future, and I'm really grateful that CCIR has provided me with the opportunity to learn more about my interests.
Yeah, I'm really glad that you had such a positive experience, and I appreciate you taking your time to share it with us. So, yeah, thank you so
Yeah, for
much.
sure. Thank you.